Imagine you are just, standing at the pharmacy counter. The technician hands you that little paper bag, and when you open it, out unspools this receipt-like piece of paper that's roughly the size of a medieval scroll.
Oh, yeah, the CVS receipt of doom.
Exactly. And it's just covered in this tiny, incredibly dense font listing, I don't know, 1,000 different ways. The little pill inside that bag might completely ruin your week.
And you probably just panic, right?
Right. Or, honestly, maybe you just throw the paper straight into the recycling bin without reading a single word of it.
Yeah.
But what if I told you that massive, legally mandated piece of paper is actually making you less safe?
It really is one of the great paradoxes of modern healthcare. We have collectively decided, for whatever reason, to equate the sheer volume of text with the actual volume of safety.
Like more words equals more protection.
Precisely. The assumption is that if we just throw every conceivable data point at a patient, well, we've fulfilled our duty to inform them. But the reality of human comprehension, especially, and this is key, especially when someone is vulnerable or sick, it paints a very, very different picture.
And that friction, that exact disconnect, is what we are tearing into today. Welcome to the deep dive. We are exploring the incredibly crucial landscape of independent medical information and, well, health literacy in general.
Because it's a landscape that affects literally everyone who takes medication.
It really does. So our mission for this conversation with you today is to figure out how we are supposed to navigate this wildly complex world of medication safety. And to do this, we're relying on a deeply fascinating source document.
Yeah, it centers around an independent medical platform called iMedix.
Right, iMedix. And specifically, we're looking at a focus area they put together titled The Versatile Shield, a deep dive into doxycycline therapy.
Which honestly serves as the perfect proxy for this entire discussion we're having today. Because we aren't just here to review a random drug. I mean, if we wanted to do that, we could just go read a pharmaceutical Wikipedia page and call it a day.
Right. Yeah, that would be incredibly boring.
Right. What we are really examining here, through the lens of this iMedix source material, is the massive and sometimes, frankly, dangerous canyon between complex medical reasoning and what a patient actually understands.
Like what they understand when they're just standing at their bathroom sink holding a glass of water about to take a pill.
Exactly. The real-world application of all that medical jargon.
Okay, so to start unpacking this canyon, I think we have to look at the environment where people actually get their medical information right now.
We definitely do.
Because the source material puts a massive emphasis on iMedix being an independent medical information platform. And I kept getting stuck on that word. What does independent really mean in this context?
It's a vital distinction.
Because I feel like every website out there claims to be independent,
They do claim that, yeah. But it really has to do with the fundamental architecture of the internet and, frankly, the healthcare industry itself.
Okay, break that down for me.
Well, when we talk about this information gap, we have to look at the default options a patient has when they want to learn about a medication. On one side of the spectrum, you have pharmaceutical promotional materials.
Right, I know exactly what you mean. The commercials with the people hiking in slow motion or riding bikes on a beach.
Exactly, the sunny beach scenes.
While a voiceover just speed reads a absolutely terrifying list of potential side effects in the background.
Yeah, and while those materials are heavily regulated by government agencies, I mean, they have to be, we cannot ignore their primary function.
Which is to sell the drug.
Right. They are, at their core, marketing materials. They are designed by corporate entities that have a vested financial interest in presenting a product in a specific light, ultimately to encourage its use.
Sure. And I mean, that doesn't make them inherently evil or anything.
No, not at all. But it does mean their foundational objective is not pure, unbiased patient education. Their goal is product adoption.
Okay, so if I am a patient and I realize I don't want to rely on a marketing team for my health literacy, my next instinct is going to be to just pull out my phone.
Naturally, you go straight to the search engine.
Right, I just type the name of the drug into whatever search bar is handy.
And that, unfortunately, brings us to the other side of the spectrum. Highly algorithmic, engagement-driven search results.
The Wild West.
It really is. This is where the landscape gets truly treacherous for a patient. Because search algorithms, they do not optimize for medical nuance. They don't care about statistical probability.
They care about clicks.
Clicks, retention, and emotional resonance. Mostly fear.
So if I search for a medication side effect, the algorithm isn't necessarily giving me the most likely outcome of taking that pill.
Not at all. It is giving you the loudest outcome.
Oh, wow. The loudest outcome. That makes total sense.
Yeah, it might push a massive class action lawsuit advertisement right to the top of your feed. Or maybe a forum post from a single individual who had an exceptionally rare, catastrophic reaction.
Because those are the links that everyone clicks on.
Precisely. The search engine feeds you fear because fear drives engagement.
So neither of these default sources, not the pharmaceutical marketing material, and definitely not the algorithmic search engine, neither of them is designed purely to give you objective, level-headed education.
No, they both have ulterior motives, whether it's financial profit or algorithmic engagement.
You know, reading through the source material, it really feels like wandering through a dense jungle without a map.
That's a great way to put it.
You're just kind of hacking away at vines with a machete, hoping you're walking towards civilization and not like off a cliff.
And you have no idea which direction is actually safe.
Right. So platforms like iMedix, it seems like they act as the compass in that jungle. Or actually, to put it another way, it's like we desperately need a nutritional label for medications.
Oh, I like that, a nutritional label.
Yeah. Because when I pick up a box of crackers at the store, I don't have to rely on the cartoon mascot on the front to tell me if it's healthy.
Right, the marketing.
Exactly. I just flip the box over and I see standardized, objective facts about sodium and carbohydrates and whatever else.
It's just the raw data presented neutrally.
Yes. And it sounds like an independent drug database is trying to offer exactly that, clear, standardized facts.
I think the nutritional label is a really strong analogy because it highlights the necessity of an educational baseline.
A baseline everyone can trust.
Yes. A resource designed purely for objective education doesn't have a vested interest in whether you actually take the medication or not.
It doesn't care if you buy the crackers.
Right. Its only goal is to ensure that whatever decision you make, you are making it based on an accurate understanding of the clinical reality, free from the noise of marketing or algorithms.
I completely agree with the need for that kind of baseline. But I actually have to push back a little bit here.
Okay, let's hear it.
Is having access to an objective database actually enough?
That is the million-dollar question.
Because if we go back to my jungle analogy, if I give someone a map, but they don't know how to read topographical lines or they don't even know how to hold a compass, does it actually help them survive?
Usually not.
Right. If a platform just hands me a giant list of objective medical facts, but I don't understand the underlying logic of my own body, I am still totally lost.
That is a phenomenal critique, and honestly, it's the exact pivot point the iMedix source material makes.
Oh, really?
Yes, because the availability of information is completely different from the comprehension of it.
Having the facts versus understanding the facts.
Exactly. The text explicitly points out that providing a database is only step one. The pervasive issue they identify is that people constantly, routinely misunderstand medication risks.
So the facts get twisted in our heads anyway.
Right. Therefore, a platform can't just be a passive repository of facts. It has to actively clarify real-world patient misunderstandings.
Because if we just list facts, we run straight into the psychology of how humans interact with warnings.
Right? Yes, we do. And there is a deeply researched phenomenon here known as warning fatigue.
Warning fatigue. Okay, let's get into that.
Let's go back to that massive package insert we talked about at the very beginning, the CVS receipt.
The scroll of doom.
Right. That document is driven primarily by regulatory compliance and liability protection.
It's for the lawyers.
Yes. It is legally comprehensive.
But educationally, it's a complete nightmare.
It is entirely useless for education, because it lists every single adverse event that occurred during clinical trials, regardless of whether the drug actually definitively caused it.
Wait, really? Even if the drug didn't cause it?
Yes. If someone stubbed their toe during the trial, it might end up in a database. So a patient reads this paper, and they see that they might experience a mild temporary headache.
Okay, totally normal side effect.
But on the very next line, in the exact same font size, it says they might experience sudden, irreversible liver failure.
Wow. My brain doesn't even know what to do with that information.
It can't process it.
It's like my car's dashboard flashing a low tire pressure light and the engine is currently on fire light at the exact same time with the exact same intensity.
That is the perfect way to visualize it. The pharmacology of the drug has been completely divorced from the psychology of the patient taking it.
The context is completely missing.
Exactly. The patient's brain struggles to triage the risk because there is no context. And the source text points out that this leads to very dangerous practical safety implications.
I can imagine. I mean, I would probably just completely abandon my treatment out of sheer terror.
And that is one very common outcome, unnecessary panic.
They see the liver failure thing and just throw the bottle away.
Right. They see a 1 in a million side effect, assume it's a guaranteed outcome, and stop taking a potentially life-saving medication. And often, they do this without ever telling their doctor.
Which is incredibly dangerous. But what's the other outcome?
The other equally dangerous outcome is apathy. This is the warning fatigue.
Oh, like the boy who cried wolf.
Exactly. Because every single product they touch has a catastrophic warning label on it. They just tune it all out.
They just start ignoring everything.
Yes. They ignore the highly probable vital alerts because those alerts are buried under a mountain of improbable legal jargon.
And when patients don't understand the why behind a warning, they start improvising, don't they?
Oh, absolutely. Improvisation is a huge problem.
Like, if I don't understand why a rule exists, I am much more likely to break it. I might alter my dosage, skip a few days, or mix my medication with something I shouldn't. All because I lack basic health literacy.
Which is exactly why the source material insists that we have to move beyond these rigid, repetitive structures in patient education.
We can't just copy-paste the same legal block of text for everything?
No, you have to explain the nuance. You have to explain the practical safety implications of the specific drug.
And this is where the source brings in their primary case study to illustrate all of this.
Yes, the focus area they put together.
The Versatile Shield, a deep dive into doxycycline therapy. I want to transition into this because it forces us to ask a really fundamental question.
Go for it.
What exactly is doxycycline used for? Because honestly, when I was rating through the clinical indications in the outline for this deep dive, my head just started spinning.
It is an incredibly broad list, which is exactly why it remains one of the most widely prescribed antibiotics in the world today.
Okay, so give me the rundown.
Well, it belongs to a class of antibiotics called tetracyclines, and to understand why the source material calls it a versatile shield, we have to look at its main clinical indications.
Bye, mommy.
It is used as a frontline treatment for severe acne and rosacea.
Okay, skin stuff.
It is also used for respiratory infections.
Yeah, lungs. Got it.
It's used for sexually transmitted infections, specifically chlamydia.
Okay, wildly different from acne.
It is the gold standard for tick-borne illnesses.
Ticks. Right.
And in selected situations, it is actually used as malaria prophylaxis.
Okay, see, let me play devil's advocate for a second here. If I go to my doctor and I am prescribed a quote-unquote versatile drug like this, I think I would actually trust it way less.
Really? Why is that?
Because we live in an era of hyper-specialization. If I have a problem with my car's transmission, I go to a transmission specialist, right? I don't go to a general handyman.
That's a fair point.
So if I look at the label on this bottle and I realize my doctor is giving me the exact same pill for my teenager's acne that my neighbor takes to prevent malaria when she travels to the tropics, and that my uncle took for a lung infection, I am going to be incredibly suspicious.
You're going to think it's fake.
Yeah. How can one single chemical compound fix all these completely unrelated problems? It feels like a snake oil pitch from the 1800s.
Cures all ailments.
Exactly. Is it just a jack of all trades but a master of none?
I absolutely love that you brought this up, because that specific skepticism is the exact friction the iMedix document is trying to resolve.
Oh, really? So it's a common reaction?
It is a completely logical human reaction to doubt a multi-purpose tool in a highly specialized world. And if a patient harbors that suspicion, they might not adhere to the treatment at all.
Because they just don't believe in it.
Right. They might think, well, this is just a generic pill. It won't actually cure my specific, unique problem.
Exactly. So how do we dismantle that suspicion? Because just telling me it works clearly isn't enough.
By doing exactly what the source advocates, clarifying the real-world medical reasoning.
Getting into the why.
Yes. We have to break down how doxycycline actually differs from other antibiotics in its spectrum of activity. We have to explain why it is chosen when alternative agents fail.
Okay, let's do it. Let's start with the one you mentioned first. Acne and rosacea.
Good place to start.
Because my assumption with acne is that it's just, bacteria on the skin, so the antibiotic just goes in and kills the bacteria, right? Simple as that.
That is the standard patient misconception, but it's really only half the story.
Oh, what's the other half?
While doxycycline does reduce the bacteria on the skin, its real superpower in dermatology, and why it is so uniquely versatile here, is that it is highly anti-inflammatory.
Wait, hold on. An antibiotic can be an anti-inflammatory, like taking an ibuprofen?
In a manner of speaking, yes. In certain doses, Doxycycline has this remarkable ability to suppress specific inflammatory pathways in the human body.
That blows my mind. I had no idea antibiotics did anything but kill germs.
Most people don't. So for a condition like rosacea, which is deeply rooted in inflammation or severe cystic acne, this anti-inflammatory property is just as important as its antibacterial property.
So it's actively calming down the skin.
Yes, it calms the angry, red, swollen tissues from the inside out.
That makes a lot of sense. But I imagine that hidden mechanism leads to a huge misunderstanding about how long you actually have to take it.
It absolutely does. And this is a major focus area for platforms trying to improve health literacy.
Because people are impatient.
Very. Think about the expectations a patient brings to an antibiotic. If you take an antibiotic for, say, an ear infection, you expect it to feel better in, what, 2 or 3 days?
Yeah, pretty much immediately.
Right. But a patient takes doxycycline for severe acne, they look in the mirror on day 4, and they see absolutely no change.
So they assume the jack-of-all-trades snake oil drug isn't working, and they just stop taking it.
Exactly. They toss it. But the clinical reality is that because it is modulating inflammation and working alongside the skin's natural, very slow turnover cycle, it can take 4 to 8 weeks to see significant improvement.
4 to 8 weeks.
Yes. And if nobody explains that timeline to the patient, if they don't untangle that real-world misunderstanding, the patient just gives up on a highly effective treatment.
Man, that really highlights the need for that context. Okay, so that explains the dermatology side of things. What about respiratory infections?
This is a fun one.
Because usually if I have a chest cold that turns into bronchitis or some kind of lung issue, they give me something like amoxicillin, right?
Typically, yes. The penicillin family.
So why would a doctor suddenly pivot to doxycycline for a lung infection?
This is a perfect example of why the why matters so much. We have to look at how different bacteria are physically built.
Built, like their structure.
Exactly. Most traditional antibiotics, like that penicillin family you mentioned, they work by attacking the structural wall of a bacterium.
Like knocking down a castle wall.
Exactly. They compromise the wall, and the bacterium essentially bursts.
Makes sense. Blow up the wall, win the battle.
But there is a category of respiratory infections, often referred to clinically as atypical pneumonias, or casually known as walking pneumonia.
Oh, I've heard of walking pneumonia.
Right. Well, those are caused by specific, unusual bacteria.
Okay, I'm going to take a massive leap here based on your setup.
Let's hear it.
Do these unusual walking pneumonia bacteria somehow not have that outer castle wall?
That is exactly the issue. They lack a rigid cell wall. So, if a doctor throws a standard penicillin at that specific infection, the drug just bounces off. It has no structural target to attack. It is entirely 100% useless.
So the catapult is just firing rocks into the air because there's no wall to hit.
Perfect analogy.
So the versatile shield has to be used. But wait, how does the doxycycline work if there's no wall for it to attack either?
Because doxycycline doesn't care about the wall. It operates on a completely different mechanism.
What does it do?
It actually penetrates into the bacterial cell and targets the internal machinery. Specifically, the machinery the bacteria uses to build proteins.
It gets inside the factory.
Yes. It jams up the gears on the assembly line, halting the bacteria from growing or multiplying, which then gives your own immune system the time it needs to sweep in and clear the infection out.
That is amazing.
And that is why it is often chosen when those alternative agents, like penicillin, are less appropriate.
Okay, this is fascinating. It really isn't a snake oil cure-all. It's just a completely different mechanism of attack that happens to work on a wide variety of targets.
Exactly. It's a very specific tool that has many applications.
Let's keep moving through these indications because I want to cover all of them. Sexually transmitted infections, specifically chlamydia.
Yes. This is another area where the mechanism is key. Chlamydia is caused by an intracellular bacterium.
Meaning it's inside the cell.
Right. It means the bacteria actually hides inside the host's own cells.
Oh, wow. That is sneaky.
Very stealthy. And because of how doxycycline is structured chemically, it is excellent at penetrating our tissues to reach those hidden bacteria.
It can slip right in after them.
Yes. But the health literacy challenge here isn't just about understanding the stealth mechanism. It's about patient behavior.
Because chlamydia can be asymptomatic, right? You don't always know you have it.
Precisely. A patient might feel completely 100% fine.
But they still have this stealth bacteria hiding in their cells.
Right. And if left untreated, it can lead to severe long-term complications, including pelvic inflammatory disease and even infertility.
So what's the educational hurdle?
It's convincing a patient who feels perfectly healthy today that they must adhere to the entire duration of the antibiotic course.
Because if they feel fine, they might just stop taking it after 2 days.
Exactly. You have to explain the stakes so they ensure the hidden infection is completely eradicated, not just suppressed.
Which again requires the patient to actually understand those stakes, not just read a generic warning label that says, take as directed.
Take as directed doesn't explain the why.
Okay, now let's pivot to the outdoors. The tick-borne illnesses.
The literal shield.
Yeah, Lyme disease, Rocky Mountain spotted fever. The source calls this a shield, and I think this is where that metaphor gets incredibly literal.
It really does. The bacteria transmitted by ticks are notoriously tricky and resilient.
Nasty little bugs.
Very. And doxycycline is considered the absolute gold standard for treating these diseases.
Over anything else.
Yes. In the case of something like Rocky Mountain spotted fever, which can actually be fatal quite quickly, it is the frontline treatment for almost everyone.
Even with the side effects.
Yes, because the risk of the disease far, far outweighs any potential side effects of the medication.
But you can also take it before you even get sick, right? Like if you just find a tick on you after a hike.
Yes, in selected high-risk situations, it acts as a literal prophylactic shield.
How does that work?
Well, say you are in an area heavily endemic for Lyme disease, and you remove an engorged deer tick that has been attached for a significant amount of time.
Gross, but okay.
A provider might prescribe a single prophylactic dose of doxycycline right then and there.
Just one pill.
Sometimes, yes. The goal is to intercept the bacteria and halt its reproduction before it can establish a foothold in your body.
Literally shielding you from the infection taking root. I love that. I am thoroughly humbled. I completely take back my skepticism from earlier.
It is an incredibly versatile drug.
But we still have one more indication to cover, and honestly, it's the one that confused me the most when I was prepping for this.
Malaria.
Yes, malaria prophylaxis. Because malaria isn't caused by a bacterium, right? It's caused by a parasite transmitted by mosquitoes.
That is correct. It is a parasite.
So how on earth does an antibacterial drug protect you from a parasite? That sounds like using weed killer on a termite.
This is one of the most fascinating quirks of biology, I think, and it really highlights why medicine is so intensely complex.
Okay, nerd out for a second. Tell me.
While malaria is a parasite, the specific parasite that causes it has a tiny structure inside of it that scientists believe evolved from a bacterium millions of years ago.
Wait, really?
Yes.
So the parasite has a tiny ancient bacterial ghost living inside it.
That is a very poetic way to put it, but functionally, yes.
That is wild.
It is. And because that internal structure shares characteristics with bacteria, the doxycycline can actually target it.
It recognizes the ghost.
Exactly. By shutting down that specific ancient bacterial machinery inside the parasite, the drug prevents the parasite from surviving in the human body.
And that's why it is used for travelers heading to certain areas where malaria is prevalent.
Right. You take it before, during, and after your trip to keep that shield up.
Okay, you have completely sold me on the brilliance of this medication. But the source material is very clear about something else.
The complexity.
Right. With great versatility comes incredible complexity regarding safety. And this is where we have to talk about absorption issues and real-world interactions.
This is where the health literacy rubber meets the road.
Because the text specifically flags dairy, calcium, and iron supplements. Now, I know I've heard the old wives' tale about not taking antibiotics with a glass of milk.
Almost everyone has heard that at some point.
But nobody ever explains why. I just thought it was to prevent an upset stomach. What actually happens?
It comes down to a chemical process, and it is a massive, massive area of patient misunderstanding.
Okay, explain the chemistry to me like I'm 5.
Doxycycline has a molecular structure that acts almost like a magnet for positively charged metal ions.
Metal ions, okay. Like calcium and iron.
Exactly. Calcium, iron, magnesium, aluminum, these are all metal ions.
Which are found in milk, cheese, yogurt.
And over-the-counter antacids in your daily multivitamin.
Right. So what happens when they meet?
When you swallow a doxycycline pill and you wash it down with a big glass of milk, or you take it at the exact same time as your morning iron supplement, the drug molecules physically bind to the calcium or iron molecules in your digestive tract.
They just stick together.
Yes. They clump together. They form what is called a large insoluble complex.
Insoluble meaning it can't dissolve.
Right. And this new complex is now physically too large to be absorbed through the lining of your stomach or intestines into your bloodstream.
Wait, so the medicine is just trapped. It can't get into your system.
Precisely. It cannot cross the barrier. So the medication just continues its journey right through your digestive tract and is excreted.
You literally just pook it out.
Exactly. You are getting virtually zero therapeutic benefit from the drug.
This is exactly what I mean about the why.
It changes everything, right?
Completely. If the warning label on the bottle just says, do not take with milk, I might look at that and think, oh, it probably just causes an upset stomach. I have an iron stomach. I love milk. I'll be fine.
People do that every single day.
But if a platform like iMedix explains to me, hey, the calcium will physically trap the medicine like a magnet, and you will excrete it without it doing anything to fight your infection, I'm never going near a glass of milk when I take it.
And that is the power of explaining the practical safety implications. If you don't separate the drug from these substances.
Usually by a few hours, right?
Yeah, usually by taking the medication an hour or two before or a couple of hours after dairy or supplements. If you don't do that, you completely neutralize your versatile shield.
It's just wild that such a simple breakfast habit can ruin a heavy-duty medical treatment.
It happens constantly.
Okay, let's talk about the sun. Photosensitivity reactions are another major warning highlighted in the text.
Oh, this is a big one.
I've heard horror stories of people going on a beach vacation, taking this drug for malaria or whatever, spending an hour by the pool, and ending up in the emergency room.
Yes, and this requires clarifying a very specific distinction for patients. This is not just a regular sunburn, and it doesn't mean you have suddenly developed an allergy to the sun.
So what is it?
It is a phototoxic reaction.
Phototoxic. Break that down for me. What's the difference between that and a regular burn?
When you absorb doxycycline normally, the drug circulates in your bloodstream and eventually deposits into various tissues in your body, including your skin.
Okay, so the drug is in the skin cells.
Right. Now, when ultraviolet light from the sun hits your skin, that UV energy is actually absorbed by the doxycycline molecules themselves.
The medicine absorbs the sunlight.
Yes. And the molecules react to that energy by releasing reactive compounds that damage the surrounding skin cells.
Oh my God. So the drug itself is reacting to the light and burning you from the inside out.
Essentially, yes. That's a great way to visualize it. It accelerates and intensifies cellular damage.
That is terrifying.
It can be. A patient can get a severe blistering burn in a fraction of the time it would normally take them to even get slightly pink.
So if you were taking this for severe acne, or for malaria prophylaxis while traveling to a tropical beach,
you have to be obsessively vigilant. Sunscreen, wide-brimmed hats, protective clothing. The shield against the disease makes your skin highly, highly vulnerable to the sun.
the shield has a massive weak spot.
It does.
Okay, there is one more physical risk we need to cover, and honestly, this one makes me wince just thinking about it. Esophageal irritation risk.
Yes. Sometimes referred to clinically as pill esophagitis.
Just the name sounds painful.
This is a profoundly uncomfortable but highly, highly preventable complication.
Okay, how do we prevent it?
Well, we have to look at the chemistry again. Doxycycline is quite acidic.
Okay, and the esophagus is the tube that connects your throat to your stomach.
Right. So if a patient takes the capsule with barely any water, or if they take it and immediately lie flat in bed to go to sleep,
The pill gets stuck?
the capsule can get physically stuck in the esophagus. And as it dissolves right there, that highly acidic medication sits directly against the delicate mucosal lining of the throat.
Oh, wow, so it literally burns an ulcer into the lining of your throat.
It does. It causes intense, radiating pain, particularly when swallowing, and it can take weeks to fully heal.
Weeks. And this totally explains the incredibly specific instructions you always see on the bottle.
Take with a full glass of water and remain upright for at least 30 minutes.
Yes. I always thought the remain upright rule was just to prevent mild heartburn or something.
Most people do.
I had absolute no idea it was to let gravity ensure the pill doesn't dissolve in my throat and burn a hole in it.
See, this is the entire thesis of the source material. These rules are not arbitrary.
They aren't just lawyers talking.
No, there is undeniable physics and chemistry behind every single warning. When patients understand the mechanism of injury, when they understand gravity and acid compliance, skyrockets.
Which leads us to perhaps the most widespread and arguably the most dangerous patient misconception of all when it comes to antibiotics.
The viral misconception.
Yes. We've talked about what doxycycline can do, but we have to absolutely clarify what it cannot do. And that is treating viral infections.
Yes. The belief that an antibiotic like doxycycline is a universal cure-all for any time you feel sick is a massive, massive hurdle in public health.
Right. People think, I feel terrible, my throat hurts, I'm coughing. I'll just use my versatile shield.
But the shield only works against specific enemies. The common cold, influenza, COVID-19, most cases of acute bronchitis.
These are viruses.
These are caused by viruses, and viruses are fundamentally different biological entities than bacteria.
They don't have the same machinery.
Exactly. The mechanisms that doxycycline uses to stop bacteria like jamming up the protein factory we talked about earlier, those simply do not exist in a virus.
So the drug has nothing to attack.
Right. It does absolutely nothing to stop the viral infection.
So taking an antibiotic for the flu is like trying to use a screwdriver to hammer a nail.
Yeah.
It's just the completely wrong tool for the system.
It is entirely ineffective. But the real danger isn't just that it doesn't work.
It's the collateral damage.
Yes, the collateral damage, because while it's completely ignoring the virus, the doxycycline is still circulating through your entire body.
And it's interacting with all the beneficial bacteria that naturally live in your gut and on your skin.
It's attacking the friendly troops.
Oh, wow. So you're just carpet bombing your own helpful bacteria for no reason.
Yes. It wipes out the good bacteria, which can lead to severe gastrointestinal distress. But on a macro global level, exposing bacteria to antibiotics unnecessarily is the primary driver of antibiotic resistance.
Which is a terrifying concept.
It is. The surviving bacteria in your body and in the environment, they learn from the exposure. They mutate.
They build better defenses.
Yes. And the next time you actually have a severe bacterial infection, that versatile shield might just bounce right off because the bacteria have adapted to it.
That is a sobering thought.
Yeah.
Okay, so if we pull all of this together, what does this actually mean for the person listening to this deep dive right now?
It means a lot, hopefully.
Because we have covered an immense amount of ground today.
We really have.
We started by looking at the desperate need for independent platforms like iMedix to cut through the noise of marketing and algorithms.
Getting that nutritional label for drugs.
Right. We unpacked the very real psychology of warning fatigue and the dashboard with the engine fire.
Yep.
And we used doxycycline to understand the staggering complexity of a versatile medication. From agent parasites and atypical pneumonias to the chemistry of a glass of milk and the physics of gravity in your throat.
It's all connected.
It is. So what is the listener's toolkit here? How do they take this deep dive and actually apply it to their next doctor's visit?
I think the toolkit is a fundamental shift in mindset.
How so?
Knowledge is only truly valuable when it is understood and applied. When you are prescribed a new medication, don't just rely on a cursory algorithmic search.
Don't just click the first scary link.
Right. And don't let your eyes glaze over that dense, legally mandated package insert either.
The scroll of doom.
Throw the scroll away if you have to. But seek out those independent, objective sources that act as a clear, unbiased nutritional label for the drug.
And when you look at that label, you have to train yourself to ask better questions.
Exactly.
Yeah.
Don't just ask the doctor, what are the side effects?
Change the conversation entirely. Ask your provider, what are the real-world implications of this treatment? Who is most affected by these risks, and why?
Yes. The why is everything.
If you demand clarity on the why you can't lie down, why you must avoid the sun, why you have to take the full course, even if you feel completely better, you transition from being a passive, confused recipient of medical care to an active, empowered participant in your own health.
I love that. Being well-informed doesn't mean having a medical degree or memorizing a massive drug database.
Nobody can do that.
It means knowing how to push past the jargon and not stopping until you get an answer that makes logical, practical sense to you.
It's about recognizing that your medication isn't magic, right? It's a tool.
Exactly.
It's a tool, and you need to know exactly how to wield it safely.
When a patient embraces that perspective, they bypass the panic entirely. They cure their own warning fatigue, and they empower themselves to navigate that complex medical landscape with genuine confidence.
They start to see the logic behind the rules.
They do. We've seen how a single drug can tackle a teenager's acne, a hiker's tick bite, and a traveler's malaria risk, all by precisely targeting specific biological machinery.
While simultaneously demanding strict respect for things like dairy intake and sun exposure.
It is a perfect microcosm of modern medicine. It's incredibly powerful, beautifully complex, and entirely reliant on patient cooperation and deep understanding to be truly safe and effective.
So well said. Embracing these multiple perspectives is what ultimately empowers the patient to thrive.
I absolutely agree.
But I want to leave you, the listener, with one final, lingering thought to ponder on your own today.
Okay, let's hear it.
We started this conversation talking about the comfort of a doctor just handing you a pill and saying, take this. It is easy to let someone else carry the cognitive load. But if we now have the tools, the independent platforms, and the deep understanding to completely demystify our medications,
It shifts things.
it really does. How much responsibility shifts from that doctor's clipboard directly into our own hands when managing our personal health shields?
That is a big question.
It's an empowering thought, but it's also a heavy one. Thank you so much for joining us on this deep dive into health literacy and the versatile shield. Keep asking the hard questions, keep demanding to know the why, and we will catch you next time.